Now let's see how this isoquant-isocos diagram looks when we put the two things together to find the minimization cost point for the firm. Let's do it in the diagram first. Now the firm faces a technological constraint that is given by, say, isoquant. That gives you all the different combinations of capital and labor that can be used to produce a specific amount of output. In this case, is Q1. So along the isoquant, all output is the same, and it's just different combinations of K and L that give you that output. Now, the firm wants to produce this output using the least amount of cost, or minimizing cost. Therefore, what the producer is going to try to do is to find the lowest possible isocost line that allows the firm to produce that isoquant. So, for instance, if this producer has the choice between this isocost and this isocost, the second one that is closer to the origin is actually is better because it produces the same output with lower cost. You see, the producer can produce here that output by using this combination, or it can also produce here. Let's say between point A and B, point B is better because it produces the same output with less cost. And as you keep moving the isocost to the origin, you will actually producing with lower cost. So essentially what you're trying to do here is to find the isocost that is closer to the origin, but it still kind of touches the isoquant. So if you continue that process, if you keep moving to the left and to the left along the isocost, keep moving the isocost to the left, and it just stops at a point in which the isocost just touching the isoquant, then that is a point in which you're going to produce with a less amount of cost. So this minimization cost problem is solved when you find the tangency point between the isocost, in this case let's call it I1, and the isoquant Q1. So at this point right here is when the cost, this is a minimizing cost solution. Okay. Notice that if you use a different combination, let's say that combination, well, you can use that, but you won't be able to produce Q1 with that amount of cost. So therefore, the isocost that you will use is the one that is just tangent to the isoquant. Now, in consumer theory, the process, as I'm sure you notice, is very similar. It's actually the same process, but in reverse to the process of maximizing utility for the consumer. Now, in consumer theory, the consumer is trying to maximize utility, which is an indifference curve, given a certain income constraint, which is the budget line. The consumer started with a set of budget constraints and tries to move along this budget constraint to find the highest indifference curve. In producer theory, the producer is trying to minimize certain costs, the isocost, given a certain technological constraint, the isoquant. So for producer theory, the isoquant is your constraint and the isocost is kind of the objective function. The producer starts with a set of isoquants, technological constraints, and try to move along the isoquant until it finds the lowest possible isocost. Okay? So let's look at how this looks when you have an actual equation by doing a little bit of calculus in a different video.